Have you ever heard the story of the apple that fell on Isaac Newton's head? It's a tale that has fascinated people for generations. It's a famous tale about a brilliant scientist who made a groundbreaking discovery that changed our understanding of the world. As the story goes, Newton was sitting under an apple tree when an apple fell, perhaps bonking him on the head, sparking his curiosity. This seemingly ordinary event sparked an extraordinary idea that would lead to a monumental scientific breakthrough. Newton began to wonder, why do things fall down? What causes this motion? This simple question set Newton on a path of scientific inquiry that would change the world forever. He realized that there must be a force pulling the apple towards the earth, a force that acts on all objects. He called this force gravity, a term that would become fundamental in physics. Newton's observation wasn't just about apples falling from trees, it was about understanding the universe. He realized that this force, gravity, was everywhere, affecting everything in the universe, from the smallest apple to the largest star. Gravity is a fundamental force that attracts all objects with mass towards each other, no matter how big or small they are. Imagine you have two magnets in your hands. They stick together because of a magnetic force which is similar to gravity in some ways. Gravity is similar, but instead of magnets, it works on everything in the universe, from the smallest particles to the largest planets. It's what holds us to the Earth, keeps the moon in orbit around our planet, and even governs the movement of galaxies across the vast cosmos. The bigger and heavier an object, the stronger its gravitational pull becomes. That's why the Earth, being much larger and more massive than an apple, exerts a stronger gravitational force, pulling the apple towards it. This invisible force of attraction between objects is what we experience every day as gravity. Newton's insights into gravity weren't just limited to its existence. He went on to develop 3 laws of motion and a law of universal gravitation, which together explained how this force shapes the universe and governs the motion of celestial bodies. These laws, published in 1687, provided a mathematical framework to understand how objects move and interact due to gravity, revolutionizing science. His work explained why the moon orbits the Earth and why the planets orbit the sun, offering a new perspective on our solar system. Imagine a ball on a string. You swing it around and the string keeps it from flying off in a straight line, demonstrating centripetal force. Gravity acts like that string, keeping planets in orbit around stars, maintaining the cosmic dance. Gap 3SS. Isaac Newton was born on January 4th, 1643 in Woolsthorpe, England. He was a curious child, always asking questions and seeking to understand the world around him. His early education was at the King's School in Grantham, where he developed a keen interest in mathematics and science. Despite facing many challenges, including the death of his father before he was born and his mother's remarriage, Newton's determination and intellect shone through. He went on to study at the University of Cambridge, where he would later make his groundbreaking discoveries. Newton's contributions to mathematics. In addition to his work on gravity, Newton made significant contributions to mathematics. He developed calculus, a branch of mathematics that deals with rates of change and the accumulation of quantities. Calculus has become a fundamental tool in science and engineering, allowing us to model and understand complex systems. Newton's work in mathematics laid the foundation for many of the scientific advancements that followed. Newton's discoveries in physics and mathematics had a profound impact on the world. His laws of motion and universal gravitation provided a framework for understanding the physical universe. These principles have been applied in countless ways, from engineering and technology to space exploration. Newton's work inspired generations of scientists and continues to influence our understanding of the natural world. Today, our understanding of gravity continues to evolve. Scientists use the principles of gravity to study everything from the behavior of black holes to the expansion of the universe. Technologies like GPS rely on precise measurements of gravitational forces to provide accurate location data. The study of gravity remains a vibrant field of research, with new discoveries and applications emerging all the time. Centuries later, a brilliant physicist named Albert Einstein came along and expanded our understanding of gravity even further. In his theory of general relativity, Published in 1915, Einstein proposed that gravity isn't just a force, but a curvature in the fabric of space and time. Imagine a bowling ball placed on a stretched sheet. The ball creates a dip in the sheet, and if you roll a marble nearby, it will curve around the dip. Similarly, massive objects like stars and planets warp the fabric of space-time around them, influencing the movement of objects, including light.